Hello YouTube, RJ. Hey, just on the bench messing around. Thought I'd grab some video, a little short video to talk about one of the things I'm working on. One of the things I bought recently is two of these little crystal filter modules. They're 10.7 meg filters. And what I bought them for was to experiment around a little bit with, but mainly because of the R10 receiver, the much discussed R10 receiver. Now, one of the things I noticed about the R10 receiver was it filtering seemed to be pretty wide on it. It's really hard to pull out individual stations. So I wondered if I couldn't improve on that. So I'm going to try to improve on these radios that we've built recently, and the R10 included. And one of the things I thought I might be able to do is find a tighter filter. What I did is I researched the filter that was in there, and I found a replacement, same company, everything, just a tighter filter. Now, how much this is going to help, I don't know. But it's something we can try to do to improve this radio. I thought I wanted to do some empirical data before I did this. Now, my intention is not to change the radio until after the shootout where we put them all together and compare them. But I couldn't stand it. I wanted to see the comparison between the two crystals. So, two crystal filters, I should say. So I pulled the one out, desoldered and removed X1 off the board. And I've got it hooked up to the spectrum analyzer, as you can see over here. And I've grabbed a capture of that. I'll put up here in a minute where we can compare the two. And so this is what I get from this crystal filter. Now, I'm not going to change any settings. You're going to see. I'm just going to change over. Now, one thing you didn't see was I was having a lot of challenge getting clipped on here. I was having to hold the two grounds on there because I don't have long leads on this one anymore. But I did that, and I got a picture of it, managed to do all that, hold it, and get an image of it. These tests are going to be apples to apples, okay? So I've got this one, and I'll go ahead and we'll hook her up. We won't change any setting. I did normalize the scope with the leads to get rid of the lead functions, to get rid of the lead losses. Normalized out the spectrum analyzer so it does not see the leads at all. That way we're measuring just this crystal filter. So let me get hooked to this crystal filter, which is a challenge. Okay, here we are with this one, and you might notice it's a little steeper skirts. It gets down to a lower amount quicker, and I'm going to turn around and pop these two images I took, these two screenshots from the spectrum analyzer up so we can look at them. Be right back with you. Here's the two screenshots of the filters. Now the top one here, A, this is the new one, and this is what is currently in the R10, or will be. I'm putting it back. As soon as we're done here, I'll go over and put it back. If you take a quick look, not a giant difference, but noticeable difference in them. I don't know how much it'll help. I don't think it's going to hurt. Let's put it that way. Might not make enough difference when you compare it to everything in the system, but you know, playing around, what the heck. You might notice up here at the top, first of all, the losses were almost a dB less loss. That's nice. It means that weaker signals will get through the filter a little stronger. Notice the width up here at the top. Notice the width at the bottom. Notice that all the settings are the same on these screens. Nothing was changed. We're tighter at the top. See how much fatter this is down here? How much steeper these skirts are here for a ways, and then they start broadening out. You're narrower through here. This is good. This is where it's going to matter the most, okay? And that's because when you have these close-in stations, this is what's going to help you the most, is that you're getting down, you're getting higher losses, you know, filtering effect quicker. It's not that the filtering is dramatically more, if you notice, okay? We drop down to, I mean, there is a difference. For example, right here at the end of the shoulders, you'll notice that you max out at probably 55, minus 55. Here we get down to, oh, I don't know, minus 58. Doesn't seem like much. 3 dB though is half the signal. So I mean, it's that's substantial difference. It's how much steeper, how more quickly we filter stuff off the sides than this filter. Again, you know, you can't get a brick wall straight down filter in analog. That you've got to go to software to find radios to do that. We do the best we can, and it looks like for this radio, for the type of filter they're using, this is probably the best I'm going to be able to do. It is an improvement. It should help some filter a little bit more of the radio stations off to the sides, okay, by only letting what we want through. It's worth a try. Hey, it only cost a couple bucks. It's worth playing around with. You know, you learn by playing. So this is a great way for us to try out a little tighter filter to see the effect and compare it to what they're using. So let me get over the bench. We'll put this crystal filter back in the R10 so it's ready to go. And then, all right, back on the bench. Okay, and let's get these out of our way. I'll hang them up in a minute. So we need to get our crystal back in. Get in there, you rascal, and stay. I don't have leads long enough to make them stay in there now, so got to get them in there and keep them in there. Oh, get me a little solder here. What we'll do is we'll just melt us a little on one of them, just enough to make him stay in there. All right. That'll get him. There we go. Got him tight against the board. Looking good. We're back together. Boom. All right. Hey, thanks for hanging out in this short little video. Just wanted to kind of show you a little about what I'm playing around with the crystal filters. Thanks for hanging in here. Hope to catch you in my next video.